I'm Sherry Horner, your host at HealthFitnessBroadcast.com. Today, my guest joins us from Philadelphia, Pennsylvania, and Ira Pastor. Welcome to the show. Thank you so much for joining us. Today, our topic is the 3 R's: regeneration, repair, and rejuvenation. Ira Pastor is a, let me see if I get this right, Chief Executive Officer at BioQuark, Inc., and that is an innovative life science company that focuses on developing novel biologic solutions for human regeneration, repair, and rejuvenation. So that's what we're talking about today. Welcome to the show, Ira. It's great to have you.
Thanks for having me.
Thanks for letting me pick your brain for this. So you've been at this for 30 years. You have 30 years experience in the multiple sectors of pharmaceuticals. So can you tell us a little bit more about what you've done? And then I have a lot of questions for you today.
Sure. By undergraduate training, I'm a pharmacist that went to business school, and I spent most of the last 30 years in some facet of the, what we'll call the traditional pharmaceutical industry, from big pharma down to smaller biotech and sales, distribution, and even retail. So sort of pharma is where I grew up, and I learned the basics, and I've been around this industry quite a bit, and sort of fed into my interest in what we're doing today, which is looking for truly innovative and transformational possibilities for human health and wellness via these rather radical approaches.
Okay, now I will include your website in the description box, so if anybody has any more information after they watch this, they can contact you. So you have your MBA from Temple, a true Philly boy, you're in that area, and you also have BS in pharmacy from Rutgers University. So have you always lived in the Philly area?
Whole life.
Life. So I just learned that we are neighbors close by in Philadelphia, and you've been doing this for 30 years. So what sparked your interest? Was there one defining moment 30 years ago that you said, this is what I want to do, and this is what I'm passionate about? One certain moment, or was it just evolved?
Well, it evolved. I mean, I came up in a family business that was involved in the retail pharmacy industry here in Philadelphia in the early 1960s. So I can guess. I say I started when I was 6 years old, washing the shelves in my father's pharmacies, and sort of it took off from there. But I think the real interest sort of came from the combination of is training as a pharmacist, sort of the combination of the scientific aspects of sort of the pharmaceutical industry, combined with sort of just what we see in the healthcare picture around us in general, that we're spending a tremendous amount of money to treat disease nowadays. And I think I have to take a current look, but I think we recently surpassed $7 trillion a year around the world. And we have simultaneously this sort of paradoxical rise in all chronic degenerative diseases responsible for human suffering and death, as well as a sort of gradual aging and growth of the population. And sort of these factors coming together that really made me a little bit more interested in looking about how we can cure some of these maladies, as opposed to just offering new treatments for them.
Okay, Ira, can you tell us more about BioQuark?
Absolutely. So BioQuark is a biologic development company that, as you mentioned, is focused on what we refer to as the 3 R's. We are interested in human regeneration, reversion of the disease state, and ultimately rejuvenation of older tissue to a younger state. The the idea for what we're doing at the company really came from relooking at nature. When you look outside humans, you have a wide range of species in the natural world that are exceptionally good at regenerating and repairing themselves. There are a wide range of organisms out there that can undergo complete regeneration of body parts, organs, limbs in perfect structure and function, including hearts, eyeballs, spinal cord, even major parts of their brains. At the same time, there are organisms that are exceptionally good at reverting the disease state. So when they do get sick in some fashion, cancer is an example, they're very good at erasing the history in that tissue and restarting from an earlier point when the tissue was not diseased. There are organisms that can turn back biologic time and start their lives over again. There are even some that can technically die and come back to life. And needless to say, we as human beings are very bad at doing these things. We have rather limited regenerative capability, and while we do possess some repair capability at the DNA level, these capabilities really drop off substantially over time as we age. And so the idea for BioQuark sort of jettisoned off of this as we sit in an era where we're spending now around $7 trillion around the globe on healthcare, $1 trillion on pharmaceuticals, and $200 billion every year on new life science R&D. And when you sort of factor out infectious diseases, the majority of that $7 trillion trickles down to diseases that either have, one, an underlying cellular degeneration, or two, an underlying cellular damage component. And we took the perspective that our industry is very good at creating treatments nowadays to deal with the sort of the signs and symptoms of these disorders, but we're very bad at creating cures. And that is ultimately sort of the background to why BioQuark was set up, is to look at alternative ways where we can look at nature and how other species undertake these fascinating capabilities and ultimately develop biologic products that can be used in humans one day and initiate or reawaken these types of regenerative and repair capabilities for disease and ultimately health and wellness. And so that is sort of the background to what we've been doing in the laboratory and more recently in the clinic to date.
Can we talk about disease reversion?
Absolutely. Absolutely.
Yeah.
So,
with my hand.
So we, one of the things when we're talking about the reversion of the disease state, and we're as a company, one of the areas we're very interested and active in is oncology and cancer, and it's one of those areas that sort of regeneration and cancer have always been, at least in the recent era with the sort of stem cell technologies and what have you, have always been sort of part of a double-edged sword. But the fascinating thing is, when you go back out to nature and you look, the most cancer-resistant organisms out there, and I say resistant because there's a lot of myths that there's organisms that don't get cancer. That's not, everything on this planet gets cancer. But when you look at the lower organisms and how they deal with it is much different than how we look at it. They don't focus on kill methodologies, which is the basis of sort of the trillions that we spend in the war on cancer. Instead, they approach cancer from a very different angle, and that is sort of taking the tissue and turning it back to an earlier state and turning it into normal tissue, as opposed to looking for an outwardly toxic response, whether that's chemo or some other kill-centric oncology methodology. So we have been very interested in studying these dynamics and how we can apply them in ultimate mammalian and then human systems. So we spent a lot of time in the laboratory for the first couple of years looking at the reprogramming capability of our biologics, both in vitro and in vivo animal models, smaller mammal models, and how we can use biologic materials, in these cases certain peptides and microRNAs to actually reset sort of the cellular state, so that instead of looking for the kill event, which unfortunately too often leads to compensatory proliferation in oncology and resistance, we'll look at how about we can reverse and erase sort of the genetic history of the disease in a stepwise fashion back to when tissue was, in essence, normal and in a non-oncogenic state. And so we've been spending a lot of time on this front. We've recently, with partners in Eastern Europe, started taking some initial first-in-human steps and some dose ranging, and we're rather excited with some of the initial data we're seeing in terms of safety and tolerability, and some initial top-line efficacy in where we're focusing, which is in our case in metastatic breast cancer. So this is an exciting area of ours. We, in addition to oncology, we have also had a focus on the kidney. The kidney obviously is a major focus of both the transplant segment of the industry, but also the dialysis industry, where we spend $60 billion annually nowadays. And we really have very little in between sort of the development of chronic kidney disease and the ultimate disposition of these patients into either of these states, which really leads to dramatic loss of quality of life. And so what we are looking at here, once again, is how we apply these biologics towards not just reversion of the underlying disease state that may cause kidney damage, and there's a wide range of kidney disorders, but at the same point, how we can regenerate parts of the kidney parenchyma and reestablish normal function versus just dumping somebody into a dialysis treatment or a kidney transplant with immunorejection drugs for the rest of their lives. So we're rather excited and active on both of these fronts.
Yeah, those are two really important issues. Mm-hmm. Let me see, I have another question for you. Okay, so what about rejuvenation and aging? So sure. we're all aging.
Absolutely.
There's no stopping that.
Well, it's interesting because, you know, as mentioned, there are organisms on the planet today that turn back time, turn back what we'll call biologic aging. They're not physically immortal, but they are biologically immortal, and they can grow up. There's certain species of jellyfish and hydra and what have you, and then later in life they just decide to be younger again and can genetically and epigenetically erase time and start life over. These capabilities, interestingly enough, are present in humans, but they are present for a very brief period of time, and that is the moments following your conception in human eggs. It is this sort of biologic window of time where age is reversed, where genetic and epigenetic damage are erased, and it is the reason why our children, for the most part, are born aged 0, with 2 arms, 2 legs, and so forth, and none of the traditional diseases associated with older age. So our goal has been, because the basis of a lot of our work is in studying the peptides, microRNAs, and other biomolecules present in eggs, what we call ooplasm, or the cytoplasm of eggs, and purifying them and applying them for these therapeutic purposes. And so we did not get a start initially with an anti-aging thrust. However, our studies, because a lot of our work, we have to do long-term safety trials in animals for our traditional drug development programs. And for the last several years, as we were undertaking these, we noticed a very interesting trend, which was the fact that the animals that were in the active drug arms of these toxicology studies started living a lot longer than the normal lifespan of the control animals. In some cases, much longer. We have mice that whose normal lifespan in the lab is anywhere between 2 to 3 years. that were living 70% longer in the treated groups. And so we realized that we had something here from a gerontological perspective that was very interesting, because obviously there's a major debate in the sector of, what aging is, what causes it. Is it an inflammation issue? Is it an oxidation issue? Is it a telomere issue? It's probably many things. But the one place, as I mentioned, that's very good at turning it back in terms of actual biologic time is ooplasm. Ladies, all ladies take a bow for this because you're responsible for it. And so we believe we indeed are sitting on a therapeutic portfolio as we develop some of the disease-centric approaches that may have some very interesting longer-term gerontological possibilities in older humans. Obviously, that takes a lot longer to study when you get into clinical trials. However, it is on our radar and definitely a part of our program moving forward.
I wanted to also ask you about your latest project. How do you say that, right? Reanima. So tell us about that project.
Well, that is it's a rather new project. It has an interesting background. Obviously, one of the areas on the regeneration front that we as a company are extremely interested in is the central nervous system. And when we talk about the central nervous system, we mean everything from chronic degenerative diseases, from Alzheimer's, Parkinson's, ALS, multiple sclerosis, as well as more acute indications, such as in cases of traumatic brain injury and other what we'll classify as disorders of consciousness, so coma and persistent vegetative state, all of which underlying problems with cellular degeneration and death. And so in our program, as we began studying not just the higher brain, but also the spinal cord, we began to realize the potential of these bioactive materials in inducing not just localized regeneration, but what is referred to in the lower animal kingdom as epimorphic regeneration. Basically, if a body part was missing entirely, how the body that remains figures out ultimately what parts to regenerate simultaneously, and then go through the stepwise production of that in perfect function and structure. And the Reanima project sort of fell in our lap as we were contacted as we were doing some of this work in traumatic brain injury and spinal cord injury, and they asked the question, well, can we take this a little step further and study what we'll say falls in a gray zone of between life and death in this area of brain death, which has, there's been a lot of very high-profile cases in the news over the years on ultimately the barrier between coma and what is defined by the original Harvard definition back in the 1960s, the irreversible coma or brain death, which is the main reason that we all die at the end of the day. And there's many reasons why we age, but the ultimate, the way we step out is always by the final death of the brain, and how ultimately we can apply these technologies, not just, once again, for the disease indications themselves, which is obviously a major important part of the program, but are there possibilities to push the envelope, let's say, a little bit further when we get into severe coma and severe disorders of consciousness, and ultimately try to bring some of these patients back from really the brink. And once again, there are species out there, there are a few that die and can reanimate themselves. And so obviously this is a much earlier state project. We are currently, actually we were breaking this news actually because we just received IRB approval for the first 30 subjects in a hospital that we'll be working with in India with a partner called Revive Life Sciences. Okay. And we'll really be able to start learning some interesting data from patients that unfortunately they just don't get the the attention or the resources or the coverage nowadays, just because of where the healthcare dollar goes. But this is a very interesting and exciting part of the entire BioQuark portfolio. And so it's something you should definitely stay tuned to.
Yeah, I'm excited about keeping up to date and finding out more as it evolves. Um, so, are there any other tips, tidbits that you can give us? Any other information that you'd like to share? Any tips for those listening that would, um, any tips that they can take home with them?
The main tip I would say is that and when I say we, I'll say, I'll go beyond BioQuark, but I'll speak for the entire sort of regenerative medicine space and regenerative, rejuvenative medicine space, that it is going to be very important in the coming years to stay in good shape, because there are going to be some major transformations in the possibilities for human health in the coming years. And at the end of the day, you want to be around and healthy for it. And whether that's technologies like ours, so the sort of the inducible endogenous regeneration space, or if we're talking about bioartificial organs, or some of the gene therapy technologies that are finally maturing, the next decade or so is going to be awash in extremely interesting possibilities that we didn't really even think about in the closing years of the 20th century. And it's really a matter, once again, staying in shape, eating right, undertaking all the traditional preventative medicine approaches to really be able to get to the era where substantial advances in human longevity and health are going to be available to all of us. And it's going to be an exciting time.
Take care of yourself, especially in the next decade, because
Absolutely.
good things are yet to come. So one more thing, Ira, I always ask everyone to share your shoe. So, do you
Absolutely.
have a favorite shoe that you can tell us about?
I do have a favorite shoe, and am I getting it on the screen here?
Mm-hmm.
Let me see if I don't want to block myself out entirely, but so this is I don't know if I'm pronouncing this correctly. This is my Saucony running shoe, and there's two very interesting things about this. It's aside from the fact that this shoe is about 20 years old, it is a very obscure size. I mean, obviously, it's a large shoe. I'm a size 15, but I always had a very thin size. It was a C. And I always got teased, and you being from the Philly area, you would understand that they used to call me hoagie feet.
Oh, okay.
But this shoe has, because just the difficulty to find something in this size, has done an excellent job, whether it has been for my own workouts in the gym or outside running or hiking in the mountains around the Philadelphia area. This shoe has walked through cities in Eastern Europe and Western Europe and China and Saudi Arabia and Mexico, been around the world, and 20 years, done a pretty good job of holding up and taking me where I want to go when I want to be active. So I don't know if if there's anything else I can tell you about it, but
I love it. I love it. I have a few that have been around, and I don't want to get rid of them. I don't wear them anymore. They're not supportive as much, but I hang on to them. So yeah, I have a favorite too. I have a favorite shoe for today, and it is another Nike. It's a dual fusion, and this is just walk around town shoe. It's not my running shoe, but it's a nice Nike makes some really good shoes. So that's my shoe for today. And I want to thank you again for all your great information. I'll have Ira's contact information below, and you can contact him for any more information. And you'll keep us updated on your
absolutely.
last program. Okay. That sounds great. Thank you so much. I appreciate your time, energy. If you like this video, please share it with your friends, subscribe. Appreciate your time. Appreciate your time, Ira. Thank you so much.
Thanks so much for having me.